Designing a given function and its inverse. So this is the basic gist of what the simple function and the inverse function will do. The input goes into the simple functions, gives out an output. That output, if given as an input to the inverse function, we get the previous d in back. It's a basic example of an encryptor decryptor. Resource utilization. This is the comparison between the synthesis phase and the place and route phase. For the simple function, this is the comparison between the resource utilizations. So basically, synthesis phase just gives us a rough estimate of the design requirements, and the information is very limited and inaccurate in some cases. There are lots of lookup tables that are unused, which are reduced in number in the post and route phase. This is the resource utilization for the inverse function. Also, the post and route phase gives detailed information, and the synthesis phase gives us a summarized information. Going on to the timing simulation. So this is the timing simulation for a simple function. The input is as here specified, and we get this output after 12 clock cycles. This is the encrypted output. Similarly, for the inverse function, we give the encrypted output of the previous two as an input here, and we get the previous input back after 12 clock cycles. The delay and speed. So propagation delay is the amount of time required for a single bit to travel from the input to the output of the design. It can also be termed as the amount of delay the input signal should remain constant so as to generate a proper output. So delay for every input output pair is different, and hence the pair that has the maximum delay can determine an ideal value of the delay, in which case the entire circuit will run. Here I found, for the 5 test cases that I've taken, I found out the max delay to be 29.49 for one cycle to execute, and that will give me the speed of my design, which comes out to be 33.91 megahertz. For this inverse function, similarly, it comes out to be 34.10 megahertz. Thank you.